Well, hello everybody. It's day 24. This is for Thursday, April 23rd. Just making sure we're all on the same page here. And let me see if I can get my little focus mouse thing. There we go. Let's read the question. This is about kinetic and potential energy. It says two basic kinds of energy are kinetic energy and potential energy. Kinetic energy is the energy an object has due to its motion. The word kinetic comes from the Greek word kinetos, which means moving. Potential energy is stored energy as a result of an object's position or shape. What happens when we combine kinetic and potential energy? We have mechanical energy. So it's those two, mechanical energy is those two things added together. How do we find all these energies? The unit of measurement for energy is joules, capital J. Potential energy equals weight in newtons times height. I'm going to pause here and point out that that's just one type that's called gravitational potential energy. Mechanical energy is kinetic energy plus potential energy. So again, it's the two of them added together. That's the mechanical energy. Graph 2.4 examines the energy of a diver. I got a little picture here for you. The kinetic energy of a 500 Newton, that's its weight, diver was measured during a dive from a 10-meter platform. 1. How much potential energy does the diver have? There's 4 questions here, so let's pause there and take care of that one first. The diver has blank of potential energy. So if you go over here and look at your little chart here, you've got height, and then you've got kinetic energy. That's not what we want. We see here we have the height, and if we go back to potential energy, which is what they're asking about, it's weight times height. Well, they gave us the weight, so there's 500 newtons. There's our weight that we need, and we need the height. Technically here, they didn't say anything about which height they were talking about, so I suppose you could be really nasty here and say, oh, well, they must have meant 0 and multiply anything times 0 is 0, but let's go with the idea that they probably meant for us to give it to them at the top of the 10-meter platform. So we need that potential energy, that weight, times the height that it's at, multiply those two together, and remember the units is joules, capital J. Question number 2 says, according to the graph, how much kinetic energy does the diver have at 8 meters? At 8 meters, the diver has blank joules of kinetic energy. All right, so in this case, they're just asking us to read the graph. You can see here you've got kinetic energy, and they said at 8 meters. So here's 8 meters, reading across. You can find that kinetic energy and answer their question. Remember to put it in joules for kinetic energy. Number 3 says, using the graph, find the kinetic energy of the diver at 6 meters. Yeah, same sort of thing. Come over here to 6 meters. And they want to know, again, the kinetic energy. So we're just going to read across on our graph, find the kinetic energy, and report that to them, remember, in joules of kinetic energy. Number 4, last question. We're almost there. Man, this is easy, isn't it? What is the mechanical energy of the diver before he dives? Well, that's not on this thing anywhere, is it? Let's go back and see what mechanical energy actually is. Mechanical energy is kinetic energy plus potential energy. In other words, it's just the two of them summed up or added together. Well, before he dives, so he's standing up here on the top of the platform. Do we know what his kinetic energy is? Well, yes, if you read the graph, you can see here that it's actually 0. He doesn't have any. Do we know what his potential energy is? Well, yeah, because we found that in number 1, remember? Or we could do it again. It's his weight times his height. So do we know what the kinetic energy plus the potential energy is? Well, sure. If one of them is 0 and we know what the potential, we can add those together and we can find his mechanical energy. Remember, the idea here basically is that it's the two things added together. If you'll notice up here at this point, remember we've talked about this before. This was first semester. Anytime somebody's standing on a high object and they're not moving, they have 0 kinetic energy. It's all potential energy. As he falls downward and his height becomes less and less, he has less and less potential energy, but he's trading it for kinetic energy. So by the time he gets to the bottom, he's all kinetic energy. Anyhow, I think that's enough for you to work on this. Everybody have fun. Enjoy your afternoon. Thank you very much.